do this. Yeah. So let's read it. So it says, the diagram shows a triangular prism. The base ABCD of the prism is a square of side length 15. So each side is 15. Yeah, that's fine. Angle ABE and CBE are right angles. Okay, that's fine. Angle EAB is 35 degrees. M is the point on DA such that the ratio of D to M and M to A is 2 to 3, right? So M is along the point DA. So M is somewhere along here, right? You know what I'm going to do? I'm going to grab this triangle again, this shape again, sorry, and just put it underneath, just so it's easier to work with. Okay, to make it big. Okay, so M is along the point DA such that D to M and M to A is 2 to 3. So that means, for example, if I get a point M, right? If it's in the ratio 2 to 3, remember what ratios are? It's like parts, right? So D to M is 2 parts and M to A is 3 parts, right? So that means, roughly speaking, that D to M will be somewhere like around here, wouldn't it? Right? M will be around here. This will be 2 parts, yeah, D to M, and then this will be 3 parts, right? And remember, well, we know D to A is 15. So remember, just from ratios, right? We can see altogether 2 to 3 is equal to 5 parts. Yeah, 5 parts equals 15 centimeters, right? Because it's DA, meaning that 1 part is 3 centimeters, and that allows us to find out what each part is. So 2 parts is 6, 3 parts is 9. Yeah. So we know what each part is. Yeah. So this is 6 centimeters, and this here is 9. And then it says calculate the size of the angle EM and the base of the pyramid. Yeah. So what I can do, let me just get my other laptop and do the line. So E to M is like here. This is E to M, right? And then the base of the pyramid, well, if I need to make an angle, it would have to be the line that goes diagonally across like this. Remember that guy that I was telling you about, the bungee jump or whatever they're called. Yeah, just imagine he's like zip lining through this line here. The angle created will be here, isn't it? Is that the angle that they want though? Yeah. The size, the angle between EF. So it's this angle that they're looking for here. Yeah, that one there. Okay. So we basically need to find out certain lengths with this triangle. Yeah. So if I look here, what can we see? Well, if I look along the floor, if I look along this floor here, I've got this triangle here, don't I? That triangle there, right? Yeah. If I draw that one out from a bird's eye view, this will be like this, wouldn't it? Look like that. And then this will be M. This will be M, B, and A. Yeah. M to A is 9 centimeters. Remember, this part is 9. This is 15. So we can work out what M to B is, right? By doing Pythagoras' theorem. So MB will equal the square root of 9 squared plus 15 squared. So I'll just put it in my calculator, just making sure you guys can see that. This will be 9 squared plus 15 squared. 15 squared. This will equal 3 root 34. I'm just going to leave it at that. 3 root 34. Yeah. MB is equal to 3 root 34. Remember, always keep it in exact value so you don't lose any accuracy. Yeah. So what I'll do, let me just do it in a different color so it's clear to see. This side here is 3 root 34. That's fine. And then what else could we work out? Okay. Well, also as well, this triangle here, this triangle on the side right here. Yeah. If I draw that triangle again, it will look like this. So I'll just draw it so it's kind of like shaped well, so proportionate. So it looks something like that. It's like a side, right? And then this angle here is 35 degrees. And then this is a right angle. This here is 15. And then this is A, this is B, and then this is E, isn't it? Yeah. And what I can do is work out what this side is. I'll call it X. And then that will be the side of the triangle that we're looking for. And then we're done pretty much. So let's do that. So using SOHCAHTOA, I know that this is the adjacent. This is the opposite. So I know I'm going to be using tan. So it'll be tan of the angle, which is 35, is equal to the opposite x divided by the adjacent 15. That tells me that 15 times tan 35 is equal to x. So I'll put it in my calculator, but it may give me a decimal. So 15 times tan 35. Okay, 10.5031. So what I'll do is say x is equal to 10.5031 dot dot dot, yeah? But in my actual calculation, I'm just gonna put 15 tan 35. So now I'm gonna draw this triangle out. This is the main triangle. What color it would be good to contrast? Maybe red, yeah? So if I draw this one out here, right? The final triangle will look like this, wouldn't it? So that part didn't work. Try it one more time. Like that. No, anyways, you guys get the picture anyway. Right angle here, and then this angle is the one we're trying to find. I'll call it Y. What do we know? M to B we knew as 3 root 34, 3 root 34. And then we now just worked out this angle, this side to be 15 tan 35. But I'll write 10.31 blah blah blah. Yeah. 10.5031 dot dot dot. Now we're finished. It will just be the adjacent side here. This would be the adjacent, this would be the opposite, right? And then we can do tan again, yeah? So y will just be equal to the tan inverse of 10.5031 dot 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 divided by 3 root 34. And then that will just give me put this in here. Tan, where is it? Tan inverse of that. Let me just write here again. I know I just used 10.3 blah blah blah, so I'll use that as answer, and then 3 root 34. And then this gives me 31 degrees to 3 significant figures. The 31 degrees.